Many students are getting confused. Does it belong to class 1 lever, class 2 or class 3? This numerical is based on the shares. Hello children, in today's class we will be solving the numericals based on levers. Especially exercise 3a, we are going to discuss each and every numerical children. So again I repeat here, to get a command in order to solve the numericals based on actually levers. So the important two formulas are very important. What are those two important formulas children here? Mechanical advantage is equal to load by effort, and one more formula is mechanical advantage is equal to effort arm by load arm. So if you know these two formulas children, if you know these two formulas, easily we can solve the numericals. And one more very important thing is that here, almost all questions, so many students are getting confused, though they know the concept, they know the formula, why they are unable to solve the numericals based on levers, you know. First you have to visualize the numerical, which means what? Each and every numerical you try to make as a rough diagram. Children, diagram may not carry the mark, but once you make the diagram, you will get a clarity. Then easily you can apply the concepts so that you get the numericals. So without doing delay children, so we will start the numericals one by one so that we can complete all numericals. As per the first question children here, it is given that a crowbar of length, so total length of the crowbar is 120 centimeters, and they said that the load is situated such a way that from fulcrum, so this is going to be fulcrum, it is a 20 centimeters. Now they are asking us to calculate the mechanical advantage. So children, this is going to be a load arm, but how to find the mechanical advantage? Mechanical advantage is nothing but what children here? Effort arm by load arm. So here load arm is given, effort arm is not given directly. The total length is 120 centimeters. From that you can subtract 20 centimeters. Then effort arm is going to be 100 centimeters, right? So this is going to be 100 by 20. So this is 5. So mechanical advantage of this given crowbar is 5. Is it clear? Fine. So as per the second question, and here is a numerical based on the scissor. Numerical based on scissor. So it is given that the blade's length is 15 centimeters and the handle length is 7.5 centimeters. So this is nothing but load arm, and here is nothing but it is effort arm. So again same formula to be used to calculate the mechanical advantage. That is here 7.5 by 15. So how can we write this is? So this can be written like this. So 75 by 150. So it is nothing but 1 by 2. 75 ones, 75 2 cities. So 1 by 2 is what? Let's say 0.5. So mechanical advantage of the scissors is 0.5. Now look at the third numerical children. This numerical is based on the shares. It is given that the blades of length 5 centimeters and a handle of length 10 centimeters. Now usually 5 kg of force is needed to cut the metal piece. But now they are asking us, as we are using the shares, how much effort is needed? So here indirectly 5 kg is what children here? Load actually. So directly we cannot calculate here. Look at here. So here mechanical advantage, we know that it is effort arm by load arm, and we also know that mechanical advantage is equal to load by effort. As LHS are fine, as LHS are equal, RHS can be equated. So here effort arm by load arm is equal to load by effort. Children, let us make a effort as a subject. So effort is equal to load arm by effort arm into load. So load arm is given how much? 5. Effort arm is 10 into 5. So this 25 by, children, it is a 25 by 10. So that is how much it is? 2.5 kg of effort is needed in order to cut the metal piece of 5 kgf. Okay? Oh, come. So now fourth numerical children. So by seeing this diagram only, they are asking us to identify the class lever actually. So how to identify the class lever here? If you can see here, fulcrum is in middle, right? So obviously it is going to be a class 1 lever. But how to call the mechanical advantage? To calculate the mechanical advantage, effort arm is needed and load arm is needed. Of course, load arm is given directly, that is 0.4. But effort arm is not given. Total length is 1 meter, that is 100 centimeters. From that 100 centimeters, this is 40 centimeters. It is 60 centimeters, means this is nothing but 0.6 meters. So this is 0.4 by 0.6. So this is going to be a 4 by 6, that is 2 by 3. So 0.6 something you will get. Now they are asking us to calculate the effort, how much effort is needed. So children, here use a similar formula here, same formula whatever we use here. So load arm by effort arm into load. So load arm is given how much? Load arm, load arm, load arm. So here load arm is 0.4, okay, by 0.6, and load is given 15. So this is 2 by 3 into 15. 3 ones are 3 5s are. Here it is a 10 kgf. From these 4 numericals, what conclusion can we draw? Observe it carefully, children. So these 4 numericals belongs to these 4 numericals are based on class 1 lever only, where fulcrum is situated in middle. Fulcrum is situated in middle. And one more thing, this is a case where we got mechanical advantage 5, which means what? It is force multiplier. And here we got less than 1, it is speed multiplier. Again here load is 5 kgf but effort is 2.5 kgf. So it is a force multiplier only. And here also, in order to lift the 15 kgf, just we have to apply the 10 kgf. So it is also force multiplier only. Okay, copy. Is equal to how much? Children, just look at the fifth numerical. It is similar to the first numerical only. So it is given that a crowbar of total length 1.5 meters is given, and it is also given that this fulcrum, so called that sharp edge, is placed 1 meter from the point where we are applying the effort. So it is nothing but the effort arm. So effort arm is how much here? 1 meter. So they are asking us to calculate even effort arm also. So as effort arm is 1 meter, children, the total length is 1.5. So how to calculate the load arm here? 1.5 minus 1. So that is going to be 0.5. This 0.5 is going to be a load arm. This is 0.5 is a load arm. Achha, tell me, does it belong to class 1 lever, class 2 or class 3? Obviously it is a class 1 lever only. How can we say that here? Because fulcrum is in between and load and effort are on either of sides. So next part of the question, they are asking us to calculate the mechanical advantage. So we know that it is effort arm by load arm. So effort arm is 1, load arm is 0.5. It is going to be a 2. Yes, so it is a 0.5 means 5 by 10. 10 will go to the numerator. 10 by 5 is a 2. Okay, fine. Now they are asking us to calculate the effort. Children, this formula already we used. Okay, now so let us use it directly. So load arm is given how much? 0.5. Effort arm is 1 into load of 75 kgf. So if you can see 75 into 0.5, 0.5 can be written as 1 by 2 into 75. This is 2 3s are 6, 2 7s are 2 5s are. So here 37.5 kgf effort is needed in order to lift the load of 75 kgf. Clear? Fine. And according to the numerical 6, children, it is given that yes, pair of scissors are used in order to cut some piece of a cloth here. And they said that from this rivet, the cloth is placed at 8 centimeters, and from the same point we are applying the effort at 2 centimeters. Means indirectly what? This is load arm, here is a effort arm. Now they are asking us to calculate the first mechanical advantage. Mechanical advantage is what? Effort arm by load arm, that is 2 by 8. This is 1 by 4. So this is 0.25. Okay. Now let us calculate the load. So how to calculate the load, children? Here we know mechanical advantage already. So we have this formula, right? Mechanical advantage is equal to load by effort. So from this, what can we write here? Load is equal to mechanical advantage into effort. So here effort is given 10. Mechanical advantage is how much? 0.25. So effort is 10. This is going to be a 2.5 kgf. Now children, in the third part of the numerical, they are asking us to just talk what is the use, how does it act, whether it acts like a speed multiplier or a force multiplier. Children, on what base we have to decide whether the given class of lever is a force multiplier or a speed multiplier? Just based on the mechanical advantage. If a mechanical advantage is less than 1 speed multiplier, greater than 1 means force multiplier. So here mechanical advantage 0.25 means less than 1, so it is a speed multiplier. It acts like a speed multiplier. Now come to the numerical 7. It seems a bit complicated, but it's an easy one only. Just you should make a diagram, then you will understand very easily. So it is given that a metal rod of 4 meters. So 4 meters I convert into centimeters, 400 centimeters. For this, they said that yes, it is a pivoted at a 125 centimeters. Okay, such a way that so it's a 125 centimeters. Obviously, let us say it's a O. So this is short arm, this is a long arm. This is going to be how much? This is going to be how much, children? It is approximately 275 centimeters. So it is a long arm, short arm. They said that a weight of load of 18 kgf is placed 60 centimeters from the pivot point on a short arm. Short arm is left side only. Now what they are asking, so if they are going to place a weight of W at a 250 centimeters from the pivot point and long arm. In order to balance it, what should be the weight of this? So here which concept should we use? We should use the concept of what? Principle of moments. So according to that, children, we know that here or else principle of moments is nothing but what? Principle of lever only. So it is load into load arm is equal to effort into effort arm. So as per the question here, load is 18, load arm is 60 and effort is nothing but the W that has to be calculated. Effort arm is 250. Now W is equal to, it is what can we write? So 18 into 60 by 250, children. So if you can calculate, you will get 4.32 kgf we get. Okay, fine. In the second part of the question, if you can see, for suppose here this W is replaced by 5 kgf, then where we have to keep this 250 centimeters they are asking. Try to understand. In the place of W, they are going to be a 5 kgf. Means in the place of here, if they will put 5 kgf, so what will be the distance they are asking? Okay, same concept, that is load into load arm is equal to effort into effort arm. So load is going to be same, they are not changing load, even they are not changing load arm also. But weight is given is 5, but they are asking us to calculate the effort arm, children. So here effort arm is equal to 18 into 60 by, it is a 5. 5 ones are 5, 12 right? Okay, na 60. So this is 18 into 12. If you can multiply, you get 216 centimeters or 2.16 meters. So we have to place a weight of 5 kgf at 2.16 meters from the pivot point. And third one, they are asking us to which class of lever does it belong? Obviously, it belongs to the class 1 lever. Is it speed multiplier, force multiplier? Yes, based on what we have to check. Look at here, 18 kgf. In order to lift the 18 kgf, children, so here we are applying 4.32 kgf weight only. So it is obviously it is a force multiplier only. Just copy it. To be calculated now. Okay, now fine. So children, as per the question 8, if you can see, a lever of length 9 cm is given and it is said that load is situated 5 cm from the fulcrum and effort is situated 9 cm from the fulcrum. So which means what here? Load arm is 5 cm, indirectly effort arm is 9 cm. So in a question they are asking us to even draw the diagram also. So this is how the diagram should be. Now to which class lever does it belong, children? As the load is in between, if you can see, it is a class 2 lever. Class 2 lever. Now here this is load arm and here is the effort arm. They are asking us to calculate the mechanical advantage. Mechanical advantage is equal to effort arm by load arm. That is what? 9 by 5. So this is going to be a 1.8, children. And if efficiency is 100%, what will be the velocity ratio? Children, just let us recall the what we can say relation between mechanical advantage and velocity ratio for a ideal machine. Here you may get one doubt, sir, why are you talking about the ideal machine now? Because efficiency is 100%. Whenever efficiency is 100% children, mechanical advantage must be equal to the velocity ratio. So as mechanical advantage is 1.8, this is also going to be the 1.8 only. But now the twist is that, so here if the efficiency is reduced to half, 50%, how the mechanical advantage and velocity ratio gets affected? Children, very simple. So very simple here. So if you can see, we have this formula, right? Efficiency is equal to mechanical advantage by velocity ratio. So mechanical advantage is equal to efficiency into velocity ratio. Now before it was 100%, now 50%, right? This 50%, try to understand. 50%. 50% means what? 50 by 100 into 1.8. 0 cancel. This is going to be a 1 by 2 into 1.8. So this is going to be how much? 0.9. So if efficiency is reduced to 50%, then mechanical advantage will become 0.9. 0.9. Yes. Now they are asking us to calculate the velocity ratio. So many students, they will think that, sir, here already it is 1.8, so it is 1.8 only. They will think that if a mechanical advantage is 0.9, here also 0.9 you will think. No, it is wrong. Why? Velocity ratio depends on the design of a given machine. Unless and until you change the design, children, velocity ratio remains constant. Is it clear? So here velocity ratio is going to be a 1.8, remains constant because we are not changing the design. So velocity ratio remains constant. Now come to the numerical 9. So diagram is given. They are asking us to find which class of lever does it belong. Children, as a load is in middle, obviously it is a class 2 lever. Now the important point is that what happens if a load is shifted towards the fulcrum? Very means how the mechanical advantage gets affected. Children, as we are shifting the load towards fulcrum means what? We are trying to decrease the load arm. So we know that mechanical advantage is equal to effort arm by load arm. So here mechanical advantage is inversely proportional to the load arm, children. So whenever you decrease the load arm, obviously mechanical advantage will increase. So just is a purely conceptual based question. Okay, fine. Now 10th numerical, children. So this question is based on the wheelbarrow. So it is given that, yes, this diagram is given in the question. So load is given 30 kgf. So everything is given, children. First they are asking us to identify the load arm. So load arm is what? The distance between fulcrum to the load. So this is fulcrum load. So this is given. So it is a 20 centimeters. 20 centimeters. But effort term means many students will take as a 40. It is wrong. Effort term is what? The distance between effort to the fulcrum. So 40 plus 20. So you should take as a 20 plus 40. This is going to be a 60 centimeters. Now let us calculate the mechanical advantage. Effort arm by load arm. So that is 60 by 20. 0 cancel. The answer is 3. Now they are asking us to calculate the effort. So we know that here effort arm by load arm is equal to load by effort. So this is nothing but what actually 3. How does a wheelbarrow act, children? It acts like a force multiplier. How can we say that? Because the mechanical advantage is greater than 1. That is the reason what we can say, a wheelbarrow acts like a force multiplier. How much effort is needed to calculate? So this is the last two numericals of this exercise, children. So if you can see, this diagram is given in the question itself. So here is a rod, let us say it's a lever, is fixed at this point, so that effort is applied here and a load of 5 kgf is applied here. And it is also given that here, children, the effort arm is 10 centimeters given and the distance between, so they did not mention effort arm, load arm actually, the distance between F and A is 10 centimeters, the distance between A and B is 490 centimeters given. First they are asking us to apply the principle of movements. Principle of movements is what, children? Load into load arm is equal to effort into effort arm. Here load is what here? So this is load. So L into load arm FB. Load arm will be FB, very important. FB is equal to effort into effort arm FA. So this is what we have to notice here. Now to which class of lever does it belong? Obviously the effort is in between. Obviously the class 3 lever. Now they are asking us to calculate the mechanical advantage. In order to calculate the mechanical advantage, we must know the effort arm and the load arm, right? So here effort arm is equal to how much? effort arm is how much? Okay, so if you can see, effort arm is 10 centimeters. And here load arm, many students will think it's a 490 centimeters. It is wrong. It is so 490 plus 10, because the effort load arm is what? That is between load and the fulcrum. So 490 plus 10, that is how much? 500 centimeters. So now mechanical advantage is equal to effort arm by load arm, that is 10 by 500, and is going to be a 1 by 50. Okay, let us keep it as a 1 by 50, so that it's very easy to us to calculate the effort. Now they are asking us to calculate the effort, children. So we know that here mechanical advantage is equal to load by effort. So from this, effort is equal to load by mechanical advantage. So effort is equal to, load is given how much? 5 by 1 by 50. So this will go to numerator. This will be 250 kgf. So this is how we can calculate the mechanical advantage. Now come to the last numerical here. So it's a fire tongs of total length is 20 centimeters is given. It is used, we are using to hold the coal of 1.5 kgf. For that, effort is applied at a point 15 centimeters from the fulcrum. Means this is nothing but what, children? Effort arm is given. So effort arm is equal to 15 centimeters, and this is going to be a load arm. So here load arm will be how much, children? It is the 20 centimeters. They are asking us to calculate the mechanical advantage. It is what? Effort arm by load arm, that is 15 by 20. So 3 5s are, what we can say, 5 3s are 5 4s are 3 by 4. It can be 0.75 something you will get. Okay, fine. Now effort they are asking us to calculate. So effort is equal to formula, what, children? Here effort is equal to load by mechanical advantage. Load by mechanical advantage. So load is already given 1.5, mechanical advantage is 3 by 4. This 4 will go to the numerator. This is 6 by 3. This is going to be a 2 kgf is a effort needed to hold the coal of what we can say load 1.5 kgf. Children, these are the numericals based on what? Levers. So children, here only, again I am telling you, only two formulas are very important. Mechanical advantage is equal to load by effort, and a mechanical advantage is equal to effort arm by load arm. So if you know these formulae, you can do like anything numericals. Is it clear, children? Yes. So children, and so these are the numericals from 3A. In the next class, we will be uploading the numericals based on 3B. Okay, children. Thank you so much. All the very best.